Okay, this is Dr. Holt. In this problem here, you have an acceleration versus time graph. And a couple things you want to note when you do these problems is you want to note what your initial position is if it's given and what your initial velocity is. The first question is, what is the velocity at 6 seconds? Alright, what I would recommend here is you know what your acceleration is. You know your acceleration. I'll put this up here. Your acceleration, and this is only going to be good from 1 to 7 seconds. It's going to be equal to this value here of -6 meters per second squared. Now you can go back to your kinematic equation. That would be what I'd probably recommend to get your 6 seconds. And we know that equation is V. It's going to equal to V initial plus acceleration times time. So I put the numbers in. V is equal to, now their initial was given as 5, plus our acceleration, which we said was -6. I'll change that to -6. And then we just multiply it by 6 seconds. Again, I'm just following just this one equation right here. And when I do that, those values, I will get V is equal to 5 meters per second minus 36 meters per second. And that will give me -31 meters per second. So that'll be my velocity at 6 seconds. Okay, now the other thing you could do is you could draw a velocity versus time graph. And again, you don't have to be that accurate, but you could draw one. So I'll do a quick one here, and I'll prove to you I'll get exactly the same thing. I come down to here, I'll come over here. This will be my time in seconds. This will be my velocity in meters per second. Now again, I know my initial was 5, is given in the problem right up here at 5 meters per second. So I'll just come over here, put like a little dot right there, and make that into 5 meters per second. Remember, the acceleration is the slope of a velocity versus time graph, so I'll just do a rough graph like this. I will come down to this value right here, and again, this slope here would represent the acceleration, and I can let that acceleration be equal to -6 meters per second squared. Alright, again, if you think about this in terms of point slope equation, or sorry, think about it in terms of y equals mx plus b, we'll write it right now. Y is equal to mx plus b. Well, what are we using for y? We're using v, so we use the v equation here. What are we using for m? It's our slope. What are we using for x? We're using t. What is b? B is going to be our y-intercept. In this case, it'll be our v-intercept. Well, look what happens when I put my acceleration back in. I get -6 meters per second squared, which is the slope, times my t, plus my y-intercept of 5 meters a second. And look what happened, and it ended up getting exactly the same equation as I had using these, by just putting in the values here for t. Because really this was just 5 meters per second minus 6 meters per second squared times t. Again, I come down here, I can put that over right there, and if I calculate it just like I did before, I will find out that this is going to cross at -31. I'm not very consistent with my colors, but it doesn't really matter. Again, we're just doing something rough here. Alright. Now, one thing you'll notice on this, 6 seconds stops here. I have not reached the very far end of this. So let's go ahead and extend this on down the full 7 seconds. Okay, and then I'll come back here and I'll make this value into, I'll do a vector, do a straight line. Make this to represent our 6 seconds here. Okay, so there's our 6 seconds right there, and I'll put that as blue. Okay, now we're going to come down to the 7 seconds. Just like that. I will come right back over here. I'll bring this line on down. I'm going to slide this up just a little bit. Okay, I'll just change these. Okay. Now, if I put the 7 seconds in here, if I did 5 meters per second minus 6 meters per second squared times 7 value, if I did that, let's think what that would give me. That would give me 42, give me negative 37. So now this value here would represent negative 37 meters per second. So I'll bring this and clean this up and bring it right back up to here. Now this velocity versus time graph from here to here is only good for the first 7 seconds. Alright, and then it's going to change, because what's going to change? Now my slope's going to go back to 9. So I come back up here, I make the slope go back up 9. Again, just something rough right now, it doesn't have to be exact. And we can say, well, what is this value going to be? What is the value going to represent on the velocity versus time graph? Well, we can calculate that. I'll show you how to do that. Because really what we need is we know what this point is right here, right? We know that it's going to be negative 37. Can we not say that negative 37 meters a second, so I'll say the velocity at 9 seconds is going to equal what I have here, and remember this value here is being at 7 seconds, right? Because we went all the way down to the 7 here. I need to go over 9, so I need to go over 2 more seconds. So can I not say plus the slope, and again the slope is your value of acceleration versus acceleration, that's going to be 9 meters per second squared, times the time interval between that, which would be 2 seconds. Okay, when I run that value, look what's going to happen. I'm going to get 30 minus 37 plus 18. That's going to give me a value of negative 19 meters per second. So we know right now this value is negative 19 meters per second. Alright, so there is our velocity versus time graph. There's my velocity versus time graph between 0 and 7 seconds and between 7 and 9 seconds. And I'll just go ahead and label that as the 9 seconds. Alright, so let's go back and look at our questions and see what the next one is. The next one says, what is the position at 6 seconds? Let's see, we've done that already, have we not? Let me check if I have not. I have not. Okay, we've not done the 6 seconds, so we'll go ahead and do that right now. Now, what we need to do now is to find the displacement. We're going to find the area under the curve. I need to know what is the area of this piece right here, and then what is the area of all this piece right here. And I'm going to color it different colors because this part is negative, and this part here is going to be positive. Well, the difficulty thing is to try to find out what is this intersection? Where does it cross the time axis? And I'll show you how to do that. We will come back over to this equation from here to here. Again, we know that is nothing more than 5 meters a second minus 6 meters per second squared times t. So I'm going to grab him, bring him down, bring him over here, take this out. We're going to change this back to t because we're going to find that intersection. I'll do that in red, in t. Now, what happens when I cross this? Well, what happens? Your velocity is 0, right? At this point, your velocity is 0. So I'll set that equal to 0. Okay, I'll subtract 5 meters a second from each side. That gives me negative 5 meters per second is equal to negative 6 meters per second squared times t. If I divide by negative 6, do I not get 5 seconds? Because my meters and my seconds here, because I got an extra one on the bottom, will cancel out. Leaves me, sorry, not 5. 5 over 6 seconds, I apologize. 5 over 6 seconds is equal to t. Again, where I'm coming from with that is just this. 5 meters per second divided by negative 6 meters per second squared is equal to t. What I mean by everything cancels out, look what happens. Meter cancels out, meter cancels out, second cancel out, second cancel out. You got one over you got the second over that down below, you bring it back to the top. Only because it's not at this level. It's not right below the line, there's 2 below the line. So I bring it back to the top, and that gives me the value of 5/6. So my time here is going to be 5/6 seconds. And that means at this point right here is going to be 5/6 seconds. Okay, so let's find the area of this. That's a triangle. The area of a triangle is 1/2 base times height. So let's say area 1 is going to be 1/2. My base is going to be the distance from there to there, which would be 5/6 of a second. Okay, times my height, and that's going to be 5. And notice your seconds cancel out here and here. I'm left with the units of meters, and we'll run that, and we're going to keep this in a fractional form. That's going to give me 25/12 meters. Let's go to area 2. We're going to calculate the area of this all the way down to 6. Okay? We need to find this distance here. Isn't the distance from here going to be 6 minus 5/6? From here to here. So 1/2 times base. That's 6 minus 5/6 times my height. Again, my height is going to be the -31 meters per second. And I should put seconds in there. Put that out there. And look what happens. Seconds cancel out. Second cancel out. Run that value there. And here you're going to get a negative value. And again, I'm going to leave it in a fractional form. Okay, so now all I have to do is add those together. When I add those together, that is going to be my displacement. That does not give me my position. That gives me -78 meters. But again, what was my initial position? My initial position was 10. So all I have to do then to say my position at 6 seconds is going to equal to my initial position of 10 meters minus 78 meters, and that gives me -68 meters. Alright, and that's where this value here is coming from. Okay, now there's nothing that says, like, you could go back to the kinematic equation and calculate this particular one if you wanted to, and I'll show you what I mean by that. We know that our final position is equal to our initial position plus our initial velocity times t plus 1/2 times my acceleration times t squared. I'll run this using the kinematic equation. My initial position we said was 10 meters plus my initial velocity we said was 5 meters a second times my t. Again, my t here is going to be 6 seconds plus 1/2 times my acceleration, and my acceleration again is going to be what the slope is, and that's -6 times 6 seconds squared. Set those off here. Now if I run that through my calculator and do that very quickly, I will get 10 plus 5 times 6 minus 1/2. That gives me exactly -68. So you can do this particular one either way. Alright, and you're going to get the same answer no matter what. Alright, so that gives you the first two. So now we're able to get these. The second one says, what is the velocity at 8 seconds? Now, again, we can come back to our velocity versus time graph, and I'll draw a line straight down. We need to find out at 8 seconds, what is this value here at 8 seconds right there. We need to find out what that value is. And I'll color code that too so you can see that. Alright, so we need to find out what this value is. So I'm going to put like a question mark right there. Actually, I'll just put a little velocity. Let's find out what that velocity at 8 seconds. Well, again, can I not just use this equation of the line? Can I not go back and say my velocity at 8 seconds is going to be the velocity I have at 7 seconds, which is negative 37 meters per second, plus the acceleration that I have here, and again that's the slope. We go back to our graph, and that has a slope of 9 meters per second squared. Multiply it by the difference in time between 7 and 8, that's 1 second. Run that value there, and don't I get negative 28 meters per second. Okay, let's check to make sure that is correct, and that is correct. Let me get rid of this question. I don't know why I left this question in here. We don't need that question. Alright, so that's how you get that one. And that's the easy one. Now, the problem about going to the kinematic equation, and it can be done, it's just a little bit more cumbersome, because you would have to find out what the position equation is going to be from here to here. And if you, again, you can do it. It's not a problem. It's just a little bit more cumbersome. And I'm going to recommend that when you have a break, like in your acceleration versus time graph, it's probably easier just to draw a rough sketch of your velocity versus time graph and find that. All right, now to the last question. What is the position at 8? Well, to do the position of 8, let's just go back and let's find out what all this area is under the curve. So this time I'm going to just make this more solid. I want to find out what is all this velocity all the way down to here. Okay? Now this isn't going to change. We're going to use that exactly the way it is. So I'm going to come down to here. I'm going to actually grab this and then we'll modify it as needed. Copy that. Come on. There we go. Copied it. Now I'll come down here. I will paste it in. Okay. Now I come back here and I say, what's the difference? Well, this part's going to be the same. Previously I went all the way over to 6. Now I need to go all the way over to 7. So I just need to change this to become 7. That's going to change this value here and change this value here. Again, all I'm doing is find the area of that triangle, and it's going to be 1/2 base times height. Oops, also need to change this too. Let's go back to our picture and see where those values come from. What is my base? From here to here, 7 minus 5, 6. What is my height? Negative 37. So I change that to negative 37. I will use those values. I will run that again, and again, let's keep it in terms of a fraction. And when I do that, I think you're going to get like minus 1369 over 12 meters. Alright, now, the next part. This is a little tricky, is we need to find out what is the area. Let me get this out of here. Get this out of here too. We're going to find out what is the area of all this right here, because all I really need to do this in purple, is add that area to it, and basically I'm done, and then add initial position. Now to do this is a little weird, is because I need to break this into a rectangle and triangle. So I'm going to draw my line straight across there. I'll color this a different color. Color this green. So we need to find this area here, and that's a triangle. and this is a rectangle here and here. Well, we found this value a little bit ago, right? We found out what velocity 8 is. So let's go back and let's add that back in. What do we say that was? If I remember right, velocity at 8 was negative 28. So we'll come back here and add that. Okay, so what is the area of this rectangle? Right? What is the height? Height's going to be from here all the way down, negative 28. What's the height? Base 1. So that's going to give me an area of negative 28. So I'll come over here and I'll say area 3 is going to equal to negative 28 meters a second times 1 second. And again, that's going to give me negative 28 meters. Alright, now I need to find out what is the area of this. The area of this triangle. What is the base? Isn't the base going to be 1? What's the height? It's going to be minus 37 minus a negative 28. Well, that's going to give me a value of negative, what's that going to be? Negative 9, right? So can I not go back and say area 4 is going to equal to 1/2 times my base of 1 second times my height of negative 9 meters per second. Run that value, we'll get negative 4.5 meters. All I have to do is add that all up, and when I do that, I think you're going to get a negative 144.5 meters. Again, that is not your position, that is your displacement. Add it back on to your initial condition of 10 meters, and that will give you a value of negative 134.5 meters. Okay, hope this video was useful. Actually, let me just double check, make sure that, yeah, that was right, negative 134.5. Again, I hope this video was useful, but this is the way I'd recommend that you step through this problem here. It's a fairly complex problem, but again, if you do it methodically and follow my approach, you should get the right answer. All right, best of luck.